structures, and I will be talking, Seth, along with Andrew Knudsen. Alright, so let's start off with, what is a Lewis structure? A Lewis structure is a structure that displays the sharing of electrons within a compound, normally drawn with several different bonds and the central atoms in the middle. So we're going to talk about the bonds within a Lewis structure. Okay, we have three different types of bonds. We have a single bond, the longest of the three bonds, and it represents 2 valence electrons. A double bond, represented by 2 lines, represents 4 valence electrons within a Lewis structure. And a triple bond, represented by 3 lines, is the shortest of the 3 bonds and represents 6 valence electrons. You only use double and triple bonds when you don't have enough electrons. Just to make that clear for everybody, so that way you're not confused when you have to use them or not. Alright, now that we've covered a few of the basic things that you would do when you form a Lewis structure, we're going to go over the actual steps to form them. Alright, and the first step that you're going to do is you are going to determine the central atom of the Lewis structure. And the way you will do that is you will look at the electronegativity chart, which will be on your reference sheet that Ms. Gates handed out to you at the beginning of the year. The only exception that you will have within the Lewis structure that can't be a central atom is hydrogen. Hydrogen will always be on the outer edges of the Lewis structure. The second part is to calculate the valence electrons in the compound. And the way you will do that is that on your periodic table, at the beginning of the year when you marked out all of the different groups, you should have on top of each of the different groups the number of valence electrons, with the exception of transition metals. So if you were to go to the farthest to the left in the alkali metals, you will have 1 valence electron, and if you continue to move right, with the exception of the transition metals, you will get 1 more valence electron per group. Okay? Now the third step in adding or in forming the Lewis structures is placing single bonds between all of the atoms. For example, here, I'll just draw a little one real quick. If you had SF2, which we will do later in the video, this is how you would start off the equation. Just place a single bond for each one to start, and if you were to need a bigger bond after that, we will have to do that based off of how many more electrons that you will need in the future. Okay? The fourth part is satisfying the octet rule. Now we're just going to go into a little bit of a discussion about the octet rule quick. Okay? The octet rule basically states that all compounds want 8 valence electrons in order to be happy. The only exception, I'll just write that down quick. All want 8 valence electrons. The major exception that you guys are going to work with this year is hydrogen. Hydrogen is happy with only 2. You do not have to have a full 8 for hydrogen, so usually if you just have a single bond with it, then that will be perfectly good for it and it will not need anything else. And then the fifth part of forming them is that if electrons remain, place them in lone pairs around the central atom. So after you've satisfied all the outer atoms according to the octet rule, which once again is that they all have to have 8 valence electrons unless it is hydrogen. There are other exceptions, I just want to note that very quickly, but the main exception you guys will deal with is hydrogen. But after that, you will add all extra electrons as lone pairs to the central atom. The sixth part of this, and check to see if the central atom has 8 electrons. Even the central atom has to be satisfied by the octet rule. Just to note that very quickly. And the last part is just to verify the structure. Alright, now that we've covered most of the basics when forming Lewis structures, let's do a couple examples here. Okay? So the first example we're going to do is write NH3, or NF3, excuse me, Lewis structure. Okay? Now, what you're going to have to do here is you're going to have to determine the central atom. And the way that you're going to do that is you're going to look at both atoms' electronegativity on the electronegativity chart that Ms. Gates gave you. And that you will find that N has a lower negativity than F. So N will be your central atom. Okay? Now, what we're going to do here, we're just going to draw the rest, or all of the single bonds to satisfy the second rule that we had applied, which was to apply single bonds to start when you begin forming a Lewis structure. Okay? And then you're going to put the 3. You have 3 of those there, so you're going to put 3 F's out here. Okay. And before that, we're going to calculate the number of valence electrons that we have. Alright. So what you're going to have to do here is you're going to have to reference your periodic table and look above each of the columns in order to get this number. Okay. If you have to pause the video, go ahead to get the numbers that you need. Now, we're going to calculate them. If you look at your periodic table, fluorine will be in the column that will have 7. Okay, but you have 3 fluorine, so you're going to add 7 3 times to get 21. Okay? Then after that, you have to look at the column where nitrogen is at, and then you have 5. And that'll give you 26. Okay? After that, you have to subtract the 6 that you get from applying the single bonds, and you'll get 20. Okay? Because there is 2 for each single bond. Okay? Now, what we have to do is satisfy the octet rule for all of the outer or terminal atoms. Okay? That means they all have to have 8. They already have 2 because of this single bond that we've placed here, so we just have to place them in lone pairs, which look like this, around them. Then you subtract 18, and you have 2 left. Okay, so now that all the outer ones are satisfied, we have to move on to the rule where it says you have to make sure that the inner has 8. Okay, and it only has 3 single bonds, which multiply or add up to be 6. So 8 minus 6 is 2, which works out perfectly. We add an extra lone pair, and that is your final answer. Okay. Alright, let's do one more, or a little bit harder example, okay? We're going to write the Lewis structure for HClO4, okay? Which is perchloric acid, in case you were wondering, okay? Now, the first thing you're going to want to do here is determine which has the lowest electronegativity. so that way it'll be the central atom. But remember, you cannot have hydrogen as the central atom. It will never, ever, ever be the central atom. So it's either going to be chlorine or oxygen. And in this case, it'll be chlorine. And then what you're going to do after that is we're going to start by placing, or first we're going to calculate the number of valence electrons that we need. Okay? Now we know hydrogen has just 1. Chlorine has 7. That'll give us 8. And then, after that, you have 4 oxygens. And oxygens give us, I believe it is 6 each. So we're going to add 4 6s to get 24. 24 plus 8 is 32. Okay. Now, we're going to scroll down a little bit and we're going to form the Lewis structures. If you need to pause to see how I got the number of valence electrons, go ahead. But here, we're going to start. We're going to have, remember we determined that chlorine was our central atom. And since we have 4 oxygens, we're going to draw 4 single bonds. One for each oxygen. Off the side, we're going to keep a running total. So since we did 4 single bonds at 2 electrons apiece, 4 times 2 is 8. Subtract 8 from 32, and you'll have 24 left. Okay. Now the next thing we're going to do here, this is where it's going to throw you a little bit of a curveball, is we have to draw the next single bond for hydrogen off the last oxygen. But you have to remember now that since we have the single bond with hydrogen, that it doesn't need any more electrons in order to be satisfied. And that'll leave us with 22 of them. Okay? Now, we have to satisfy the octet rule for all of the outside atoms. So, they all need 6. Alright, now, since we have 22 electrons, each of these outer electrons here is going to need 6. Since they all have 2 already taken by the single bond formed with chlorine. Okay? So you're going to put 3 lone pairs, or 6 valence electrons, around each, except for the outer hydrogen or oxygen over here. And the reason for that is it's already got 2 single bonds formed. Okay? You're only going to put 2 lone pairs on that one. Okay? So you're going to have 6 up there, 6 right there, that is 12. 6 right there, that is 18, and then 4 more there, that is 22. So you subtract 22 from 22, and you get 0. There is your final Lewis structure for... And as you can see, we'll just verify it one more time. All the outer ones have 8 electrons except for hydrogen, which is okay. That is the exception that we talked about. And then we move inward to the central atom, and chlorine does have 8 valence electrons surrounding it. So, that is correct. Alright, now you should be able to know how to do the different things that involve Lewis structures, and bye, have a great time.